Hi, welcome to the first video of the first project of my new blog. And this project is about building a device that automatically switches on and off the street lamps during evening and morning times.
My presentation begins with the question, why do we need the automatic switching of street lamps? Before answering the question, let me give you what are the drawbacks with manual switching. Nowadays, manually operated street lamps are not switched off properly even after the sunrise, and they are not also switched on earlier before the sunset. So this time delay causes a power loss. So power loss due to time delay is the worst and the main drawback of the manual switching. Let me give you an example to show you the power loss caused by this time delay. Generally, electrical energy is measured in watt hours. So let me consider a 100 watt bulb. A 100 watt bulb consumes 100 watts per hour. Let us calculate it for a minute. A minute is the 60th portion of an hour. So 100 by 60 equal to 1.67 watts. So a bulb consumes 1.67 watts per minute. Let us consider a bridge with 100 lamps. So 1.67 into 100 equal to 167 watts. So 167 watts are wasted per a minute over the bridge. So now let me consider a city with 2000 lamps. 1.67 watts into 2000 equal to 3340 watts, almost 3.34 kilowatts. So 1 minute time delay causes to the energy wastage of 3.34 kilowatt. So the answer is the automatic switching is must to save the electrical energy. Let us have a look on the components and the materials what we need for the project. My circuit needs a 12 volts DC power supply to operate. So I am going to use a 606 volt 500 milliamp transformer, few diodes, and a capacitor of 1000 microfarad at 25 volts, a 7812 IC, regulator IC, a half watt 1K resistor, and the LED as the indicator for the power supply. And these are the dark sensing components of the circuit: a 1K resistor, 200K trimmer, the light dependent resistor, a transistor 2N2222, and a 12 volt relay, maybe SPST or SPDT. We need a breadboard and the jumpers to verify the circuit. After the verification of the circuit, we need to prepare some PCB for the circuit. So we need some copper glass, glossy sheets, printer, iron or the laminator, ferric chloride, and acetone, IPA, such things. So after preparing the PCB, we need to assemble all the components of the circuit. So we need a box. I didn't find the transparent box, so I am using this transparent box as the project box. And you need some studs, some screws, a fuse holder, and some PCB wires, some drill. Let me show and explain the schematic circuit diagram now. The circuit needs the DC excitation of 12 volts. So I powered the circuit with 12 volts 500 milliamp transformer and a bridge rectifier, and I used a millifarad or the 1000 microfarad capacitor and a 7812 IC for better DC output, and I connected the LED with a series resistor in parallel with the two output terminals as the indicator of the power supply. So here is the dark sensing part of the circuit. So I used the switching character of the transistor here. So let me explain its working during daytimes and night times. During daytime, the light falls over the LDR. So the LDR's resistance get minimized. It's almost equivalent to few ohms. So at the time, the current passes from 1K resistor to the ground through the LDR. But nights, the light stops falling over the LDR. So at the time, the resistance of the LDR rises to peak. It's almost goes to the range of mega ohms. so almost it becomes the open circuit. So at the time the current passes from the resistor to the base of the transistor here. So at that time this circuit gets complete and the relay get excited and powers the load here. By this time many of you have found the error in the circuit. This short must be before the fuse, because when the AC load drags more current than half amp, the fuse blows out. So that is the correction in the circuit. Let's have a look on the breadboard work now. I connected the entire power supply circuit at once. Next step is to connect the resistor and a potentiometer in series with the resistor, and the LDR in series with the potentiometer, one of it end going to the ground, and the second part of the circuit, the diode and the transistor whose emitter is grounded, base is given to the LDR potentiometer junction, and the collector to the diode, and finally connect the relay across the diode ends. So next half of the circuit is done. So connect the power supply to the light sensing components. So thereby our breadboard work is done.
The breadboard work is almost done now. It is the testing phase. I connected the two output terminals of the relay to a multimeter and have set the multimeter to the diode mode or the connectivity mode. So instead of a bulb, I used a multimeter. So when the circuit works, the multimeter gives a beep sound. So let me check it now. It's working. That's a good result.
Let's move to the final stage of the project, the assembling. The first stage of the assembling is to mark the positions of the components so that we may drill holes and fit them. First I attached the fuse holder, later I attached the transformer and drilled the holes for the PCB. Before attaching the PCB to the box, solder all the components on the wires to the PCB, place the screws and the studs in position, place the PCB over the screws and tight them fitly, and the next step is to pull out all the wires through a single hole like this. Next, solder the mains, make a hole to the cover for LED. The LDR is very sensitive item. It's better to place in a transparent plastic box. Now place the fuse in the fuse holder and adjust the sensitivity. Now it's almost done. This is the input plug and this is the output socket I had. The final step is the labeling.
Successfully completed the project. Now it's time to check the final working of the device. So I connected the input to the mains and the output to a power saving lamp, and here is my LDR. Powering the mains. The device works good. One thing you have to note down here is not to place the LDR closer to the bulb. Let me explain why. During night times, the LDR activates the bulb. As soon as the bulb starts glowing, the light falls over the LDR and stops the circuit. And again the LDR powers on the lamp then. So that cycle continues. Let me show you that abnormal result. The device may be damaged in that condition. That's all about the automatic switching of street lamps. If the video is good for you, please like it and don't forget to subscribe. See you next time with a new project.